All right, guys, we have another theorem on the back side here. This one's called the side splitter theorem. And so it's going to look extremely similar to the mid-segment theorem. But you'll notice the line in the middle here. It could be in the middle, but it doesn't have to be. It could be higher or lower because these do not have to be midpoints. So these are just points, okay? Don't have to be midpoints on two sides of the triangle. And when you connect them, this segment here is going to be parallel to your third side. So it says a line is parallel to one side of a triangle if and only if it divides the other two sides proportionally. And so when that side is drawn in there that's parallel, that line segment there, all right, this piece up here, this piece down here, this piece up here, and this piece down here are in proportion with each other. So even though these two lower pieces aren't sides of a triangle, what they say is that those four pieces that I marked with X's can all live in a proportion or a fraction equal to a fraction together. Okay. Same thing here. You can use the full sides on either side as well. So all six pieces there are in proportion. So you just have to, when you set up your proportion, your fraction equal to a fraction, just make sure you have a corresponding length to the one length that you're using. Okay. So here we go. In number 4, it says that in the diagram of triangle ADC, okay, below, it says that EB is parallel to DC. It says that AE is 9, ED is 5, AB is 9.2, and they want to know the length of AC. So I'm going to go ahead and put a little bracket here because they're trying to ask me to find that length. So I just have to go ahead and find 4 pieces, okay, to use since this is what we call a side splitter. Okay, this piece here, this line segment that's parallel to my third side, is splitting this side on the left called AD proportionally to the side on the right called AC. Okay, all right, so I'm going to go ahead and highlight because I find that's the best method. I always go ahead and highlight what I am solving for first. And now I have to find something that matches it. And what matches my AC on the right-hand side would be my length here called AD on the left-hand side. And I have to do a little part plus part. 9 plus 5 ends up being 14. And 14 is what's going to correspond to my X. Okay. And now I need one more set of pieces that match. And you'll notice down here I have 5, but I don't have BC. But up here I have 9 and I have 9.2. And so now I found my 4 pieces, and now we're going to go ahead and put them in a fraction. Equal to a fraction called a proportion. Oops. All right, so now we're going to go ahead and take our X over our 14 and put that equal to 9.2 over 9. So you can see that I went from the right-hand side to the left-hand side, and then the right-hand side to the left-hand side for my second fraction. So both fractions are set up the same. And so now we'll cross multiply. This is when we get 9x equal to 14 times 9.2, which is 128.8. We'll go ahead and divide both sides by 9, and x comes out to equal 14.3111, All right, but they said to the nearest tenth, which is the first decimal. Look next door, and we'll go ahead and say that AC is equal to 14.3 to the nearest tenth. All right, let's go ahead and take a look at the next question. In number 5, it says that in the accompanied diagram that DE is parallel to BC, okay, that DB is 6, AE is 8, and they make this one a little bit complicated where they say that EC is 3 times AD, so I'm going to go ahead and put an X on AD so that I can do 3 times X, which is 3X for EC. Okay. This is indeed a side splitter theorem. You can see you got the 2 pieces above the parallel line and the 2 pieces below. And so that's perfect. So we'll go ahead and highlight X since it's what I'm solving for. X corresponds to 8. And then my 6 corresponds to my 3x. And we're going to take those pieces and put them into a nice proportion. So we'll go ahead and say that x over 8 will be equal to 6 over 3x. We'll go ahead and cross multiply. X times 3x, be very careful, is 3x squared, equal to 6 times 8, which is 48. We'll go ahead and divide by 3 and get x squared equal to 16. Okay. And then we'll go ahead and square root, because a square root and a square cancel each other out. They're opposites of each other, and x comes out to equal 4. And since they wanted to know what AD's length was, and AD is x, then AD is 4. If they asked about EC, I would tell them 3 times 4, which is 12. Okay. All right, one last one. It says in the diagram below of triangle ABC, we have DE parallel to AB. All right. That CD is 4. That CA is 10. That CE is x plus 2. And that EB is 4x minus 7. Okay. So I'm going to go ahead and highlight so I can see what I have that matches. Since I have to solve for x, I'm going to go ahead and highlight x plus 2. I highlighted that first because I can see that it matches with my 4, and so I already have one fraction good to go. Okay. There are 2 things that I could do. I could use the 10. However, I would have to go ahead and find matching side over here that corresponds to 10 by adding those expressions together. If I did add them together, I would get a 5x minus 5, and I could use that in correspondence with the 10. Or I could do one a little bit easier and say that this piece down here has to be 6, so that 6 plus 4, part plus part equals my whole, which is 10 on that side. And I think that that's a little bit, easier to do and use the 6 with the 4x minus 7. But either one, it doesn't matter. You could use the 10 with the 5x minus 7, all right? So you got 3 different, but you don't want to set up 3 fractions and cross multiply. You can only cross multiply with a fraction equal to a fraction. So you pick whichever's easiest, okay? I'm going to go with the 4 over the x plus 2 equal to the 6 over the 4x minus 7. All right, we'll go ahead and cross multiply. Be careful, it's 4 times 4x minus 7 equal to 6 times x plus 2. If we distribute, we end up with 16x minus 28 equal to a 6x plus 12. Okay. I'm going to go ahead and subtract my 6x, and I end up with 10x minus 28 equal to a 12. I'm going to go ahead and add my 28 to my 12, and I'm left with a 10x equal to a 40. And then I'm going to go ahead and divide by 10. And x comes out to equal 4. However, they want to know the length of CE, so when I go back and look at my picture, CE is x plus 2, and so this ends up being 4 plus 2. And now I can tell you that CE comes out to be 6. And that one's done. All right, I'll see you guys on day 10 for some more practice with this.